Hello, math students. This is Mr. Kraft coming to you from my house. I want to talk to you about changing fractions to decimals and decimals to fractions. I have made individual videos of this that are already up on my YouTube station, but I decided to do a new one. You notice when I said hello, students, I'm not addressing any particular grade because this uh, is relevant to several different classes, and I'm going to do them both together. So we want to say, first of all, how do you change a fraction to a decimal? And changing a fraction to a decimal is actually harder than changing a decimal to a fraction. So we get the hard part over with first, then it's easier. So let's take something like 3 over 4. Well, actually, no. Let's start with something even easier than that. Let's start with 1/2. The rule for how you do this is you put the numerator, which is the top number, inside the bracket and the denominator outside the bracket. So I'm going to say 1 inside and 2 outside. Then I'm going to put a decimal after 1. I'm allowed to do that because 1 is really the same thing as 1.0. The decimal is understood to be there. We just don't normally do it. You wouldn't normally say I'm holding up 1.0 fingers. You'd say I'm holding up 1 finger. But the 0 and the decimal are understood to be there. I bring the decimal straight up, as always. And this is technically optional, but I want you to use it. To the left of the decimal, put a filler 0. Because if you had 0.2 and you made your decimal very light, it might be harder to tell what you're talking about. But 0.2 is very clear what you're talking about. Okay, so you put the numerator inside the bracket, put a decimal after it, and add a 0. Sometimes you need more zeros to add, but we'll see. Then 10, I treat it as if it's just 10. When I start the division, I ignore the decimal. 5 times 2 is 10. Boom, that's over. No remainder. So 1/2 is therefore equal to 0.5. Okay. An example where you have to go to 2 places is 3 over 4, 3/4. I do the same thing. The top number goes inside the bracket. The bottom number goes outside. I put a decimal and a filler 0, and I'm going to have to add 2 zeros. So 4 times 7 is 28. Borrow from the 3, leave it a 2, make that 10. 8 from 10 is 2. Drop the next 0. 4 times 5 is 20. So 3/4 equals 0.75. Easy peasy. Sometimes you have to go 3 places. 1 over 8. Same thing. 1 goes inside because it's from the top. Bottom goes outside. Decimal, filler 0. 8 times 1 is 8. That's the hard part. 8 from 10 is 2. Drop 0. 8 times 2 is 16. 16 from 20 is 4. Drop the 0. 8 times 5 is 40. So 1 over 8 equals 0.125. Now, sometimes you have other things happen than this. If you had 1 over 3, and many of you probably know this already, 3 times 3 is 9. That's 1. Add a 0. 3. So it's repeating. It goes on forever. There's 2 ways you can do this. You could just say, put a bar over the 3. That means it repeats. Or they might tell you to round it. This is the tenths place. So if you rounded it to the nearest tenth, you would just say 0.3 and have done with it. Nearest tenth. Now, if you did nearest hundredth, you'd have tenths and hundredths. And you always look at whatever the next digit is. You know, you've probably heard it before. 5 and above, give it a shove. 4 and below, leave it alone. 3 is less than 5, is 4 or below, so this does not round up. The nearest hundredth would be 333. Nearest thousandth, sorry. And so forth. All right. Now, sometimes you have something like this. So 6 goes into 10 one time with 4 as the result. Add a 0. 6 times 6 is 36. So nothing has repeated yet. But now, 6 times 6 is 36. Now it repeats. So if I were to use the bar notation, I have to do this. It goes only over what repeats, because what this means is the 6's go on forever. If I did this, that's not the same thing. This would mean 1 6, 1 6, 1 6, 1 6, ... So this here is not the same as that. And in fact, that would be wrong to give for an answer for that. So, if you rounded this, you're going to get kind of different things. If you rounded it to the nearest tenth, 6 is 5 or above, give it a shove, so it would go to 0.2. That would be the nearest tenth. If I said the nearest hundredth, well, tenths, this is the hundredths place. That's bigger than 5, so it goes up to 17. So basically what happens in all of these is you go until it stops, or you go until it repeats, and use a bar over the repeating digit. Or you go to the specified place, which is a fancy way of saying the place it tells you, the book tells you to round to. Go until it stops, go until it repeats, go until it tells you where to round to. So, for example, if I had 1/4, I'm going to do this. 4 times 2 is 8. 4 times 5 is 20. It stopped. No remainder. That's what I mean when I said until it stops. I should have been more specific. When it stops, that means you have no remainder. So I went until it stops. 1/4 is 0.25. Boom, that's it. The example I just showed you, I'll do a different one this time. Another possibility would be go until it repeats and show the bar. 9 times 1 is 9. So you're going to get a repeating 1. So you could say just 0.1 with a bar over it. So that's a second possibility. You go to the repeats and put a bar. Third possibility is you go until you go to the specified place. Like if I said nearest tenth. Well, no, let's not do that. That's not too interesting. Nearest hundredth. So you will have to take it one more place out to know how to round. So I'm going to put in 2 inside the bracket because it's a numerator. Put the 7 outside. 2 times 7 is 14. That leaves you 6. This is my tenths place. 8 times 7 is 56. And that's my hundredths place. Now, that's where I want to go to, but I don't know if I'm going to shove that 8 up to make it a 9 or if I'm going to leave it alone. So to find out, I have to go to the hundredths place. And 5 times 7 is 35. 5 and above, give it a shove. So 0.29. That's all I would have to do. Now, 7 is actually going to go, 7s are always kind of crazy. They go out about 6 digits or so before they repeat. I'm running out of room, so I've got 10. 7 times 1 is 7. 4 times 7 is 28. Then I finally come back to the 2, so it's going to repeat. So if I were using bar notation over this, it goes 1, 2, 3, 4, 5, 6 digits, and the bar goes over the whole thing because the whole thing repeats 2, 8, 5, 7, 1. Whoops. 2, 8, 5, 7, 1, 4, 2, 8, 5, 7, 1, 4, dot, 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 dot. But I just show that to you so you would see what it would do. If it tells you go to the nearest hundredth, for Pete's sake, don't go further than you have to. You could just stop there. That tells me that I round that up, and that's done. Okay. Now that we've done the hard part, let's do the easy part, which is decimals to fractions. So if I had 0.4, well, you know your places. You have your tenths and your hundredths and your thousandths. I'm just using zeros to indicate, and so forth. So you look at the very last digit after the decimal. This 0 here, you forget that filler 0 you're not fooling with. The last digit is the only digit after the decimal is 4. What place is that? It's the tenths place. So you stick the place on the bottom. Easy. Easy peasy. Of course, you have to reduce it. 2 goes into 4 twice, and 2 goes into 10 5 times. So that's what happens. Easy. Suppose you had 0.45. This time you go tenths, hundredths. So the hundredths place is the last. So that's what goes on the bottom, and 45 goes on top. And of course, 5 goes into 45 9 times, and 5 goes into 100 20 times. So that's your final answer there. And by the way, the same thing applies for something like this. If I had 7.4, well, the 7's not changed. It would just be 7 2/5. You do the same thing to the 0.4 that you did up here. If you had 11.45, that would just be 11 9/20. And I should have said this earlier. Same thing the other direction. If you said 3.5 changed to a decimal, well, you know a half is 0.5. So the 3 is left alone. You go through the process to change a fraction. 3.5 is 3.5. So it just depends upon which direction you're going. Okay. So decimals to fractions are very easy. You just find the last place, put that number in the denominator, like in this case you had hundredths, so that goes in the bottom. Put the number itself on top, then reduce if you can. You can't always reduce. I had 0.123. The last place is thousandths. So you'd have that, have 123 over it, and 123 can be divided by 3, actually, because if you say 1 plus 2 plus 3, 1 plus 2 is 3, and 3 plus 3 is 6. And if you remember your divisibility rules, and I've got a video of those up in my YouTube also, if the sum of the digits is divisible by 3, the number is divisible by 3. So 123 is divisible by 3. Unfortunately, 1,000 isn't. So you can't do that. 1,000 is divided by 5, and 20, and 25, and 10, none of which go there. So you just stop, leave it alone. That can't be reduced. That's it. I hope this has been helpful, everybody, and I will talk to you later. Bye.